All right, we are on question 6 on the study guide. For question 6, we are using this graph to essentially find all of the sides and angles of this triangle. So there are 3 things that we should be able to pick out with no calculations just by looking at the picture. The first is the measure of angle B. So this is a right triangle. It has to be a right triangle. It's on a coordinate plane. So the segment AB is perpendicular to BC. So we know that that is a 90-degree angle. So we're going to write that down just from our observations. All right, the next thing we also know is we know the lengths of AB and the lengths of BC. So if I look at this, if I just count my way over from A to B, I'm going to move over 1, 2, 3, 4, 5 units. So segment AB is 5 units long. Segment BC is just 2 units long. I'm going down 2 units. So right away, we can fill in the length of AB and the length of BC. All right, so next up, let's find AC next. To find AC, we will need to do some calculations. If you find AC first without knowing angles A or C, you've got to use the Pythagorean theorem. You could find angles A or C first using trigonometry and then use trig to find the length of AC. I think that's harder. So let's use the Pythagorean theorem. I'm going to call this H for hypotenuse. And we know that we're basically using a squared plus b squared equals c squared. You could call it c if you want also. So 2 squared plus 5 squared equals h squared. All right. 2 squared is 4, 5 squared is 25. When we add those up, we get 29 equals h squared. Take the square root of both sides. The square root of 29 equals h. You can write that because the square root of 29 is a simplified radical. So we could write the square root of 29, or in your calculator, my batteries are low, you could do the square root of 29, hit enter, we get 5.385. So either that or approximately 5.385. Now to find angles A and C, we've got to find one of them using trigonometry because otherwise we don't have enough information. I'm going to just label this. I'm going to call it the square root of 29 over here. Once we find either angle A or C, we could then use that angle sum theorem and say that we know these 3 angles add up to 180. So let's find angle A first. If I look at what I'm given, although I know all 3 sides, I'm tempted to use the tangent function since I'm pretty definitive that this is 2 and this is 5. And who knows, maybe I made a mistake calculating this one. So I'm going to say the tangent of angle A is equal. We know tangent is opposite over adjacent. So opposite is my 2, adjacent is my 5 for angle A. So now I would take the inverse tangent of both sides, and that results in the inverse tangent of 2/5 equals the measure of angle A. So if we go to our calculator, the inverse tangent of 2/5, we get 21.801. So we are going to approximate that angle to be about 21.80, oops, I wrote it backwards, 801 degrees. So 21.801. Okay, I can't write and talk at the same time, apparently. So lastly, to find angle C, we could use the inverse tangent function again. You could also use inverse sine or cosine if you want to involve that hypotenuse. But we know that these 3 angles have to add up to 180. Since B is 90 degrees, we really know that A and C are complementary or have a sum of 90. So I could instead say that C is going to be 90 minus 21.801. So in my calculator, 90 minus 21.801, I get 68.199 degrees. And if you were instead to use the tangent function, that would be like the inverse tangent of 5 halves to get angle C. So if you wanted to check yourself another method, the inverse tangent of 5 divided by 2, we get 68.1985, which rounds to 199. All right, that is all you need to know for problem 6.